Okay. Wow, got your attention. So this is the final talk in the morning session. So we've just got 10 minutes for this talk, so I'll try and be quick. It's actually a dual talk between Snowflake and Data EQ, and we've got Daniel Mannino and Leah Fleckner. Daniel, at Snowflake, they take care more of the infrastructure, and Leah Fleckner, who's a data scientist at heart, I hear, but she's moved into sales and engineering at Data EQ, and they will explain a bit how to have some tips and tricks to speed up the process of getting your data projects and prototyping out there. So welcome.
Thank you. Thank you very much.
Hello. Is this on? Okay, perfect. Okay. Right, so I'm going to try and not stand in front of the slides too much. We are aware that we're the last thing standing between you guys and your lunch, so we will try to keep it crisp and a little fun. Maybe if you tip on to the next one. Okay.
We can manage terabytes and terabytes of data, but when it comes to presentation, we always have a problem. No.
Yesterday's keynote, we heard that you should be able to give a presentation without slides.
Okay.
Oh, we
well,
can try that. Okay.
It's a
okay.
challenge.
It's
a challenge.
Okay.
Let's go.
We can do it.
Why don't we start with the introduction and then just...
Yes, please.
Right?
Yeah.
Okay, so I really quickly want to introduce myself as well. My name is Leah Fleckner. There we go. Perfect.
Yeah, we don't.
So we have already been introduced. So yes, we will try to adhere to this wonderful title of getting to data science products quickly, right? So how can you shortcut the whole process to get there? Again, next slide, please. Nope, it's not working.
Okay, no slides. Okay,
no
come
slides.
on, let's
Whatever.
do it.
All right.
Right.
So my name is Leah Fleckner. I work at Data IQ. I'm a sales engineer, data scientist at heart, and this is my friend Daniel Mannino.
Daniel Mannino, I'm a principal. Oh, wow, okay.
There we go.
Yeah, because I spend a lot of time in Photoshop to enhance my picture. Daniel Mannino, principal sales engineer at Snowflake. We are the data cloud, so it's a solution to ingest your data in the cloud, manage your data, do data science on top, but we need a nice and wonderful interface on top, and this is Data IQ, please.
Okay, so let's dive in, I guess.
Yep. So let's say today we're going to play a little bit of a role playing because we don't want to bore you too much. I'm not a data scientist, so I'm going to play the role of the data rookie. Okay, data science rookie, the wannabe data scientist. And Leah, who has a lot of years of experience in data science, will play the role of a data scientist. Today, as a project, we have a project with 250 terabytes of genomic data and 30 terabytes from hospital data. And what we want to do is build a machine learning model that will tell us if a variation in a gene can predict a disease. I work in the pharmaceutical industry. It's something that we do quite often. And I'm tasked with this project. And as a rookie data scientist, I'm already exhausted. I'm destroyed because this is what I have, a laptop. And this is what the business asks for me. Does it sound familiar? Does, yes, it does. So, look. What I want to do is that I start with my laptop. I bought a new laptop. It's a fantastic laptop. Tons of memory, tons of GPU, CUDA, whatever it is. I have a lot of memory. I have a 4K beautiful screen. I can watch movies, beautiful things. And, dear, give me the data, please, and we can start this project. Is that easy?
Daniel, it's not that easy. Unfortunately, I have to tell you. So the first thing that I would argue here is if you prototype your, project on your laptop, how are you going to collaborate? How are you going to document the whole thing? How are you going to automate the whole process further down the line, right? So once you've created your prototype, you actually want to create that wonderful dashboard that your users are expecting. So how are you going to get there? And then the other thing is that data, right? You already know where it is?
Somewhere.
Did you already get access to it? And do those people know that you're going to copy your data onto your local machine? and take it home with you? Where it
Well, I
can be,
haven't
you know,
told them,
where it
you
can be
know.
stolen from your laptop?
Stolen? Where is Switzerland? It's illegal to steal stuff in Switzerland. It doesn't happen. Oh, come on. It doesn't happen. But I have an idea. I can fix it easily. Instead of my laptop, let's do like this. I go to the cloud. Virtual machine, beautiful, big virtual machine in the cloud. I bring all the data there, all the beautiful scalability of the cloud, all the power of the cloud. Hey, and I can, when I train the fantastic neural network, whatever it is, XBoost, XG, blah, 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 I can watch a movie on my laptop.
Daniel,
I fix it,
I'm
did
going to take you through it again, okay? So, virtual machine is nice. It's great. It's in the cloud. Maybe multiple people can access this, right? And you can collaborate a little bit on it. You can actually, right, get some challenging, maybe some reviewing going. But still, documentation and, you know, quality metrics, monitoring, automating the whole thing, bringing it into production. You're probably going to have to copy your data first and work on a sample of it, and then you will have to, you know, work with a single-threaded machine there. And I mean, you can scale it a little bit, you know, make it bigger, but it's not going to solve your problem, I think.
This data science change of career is getting a bit hard here, but I have a solution for that as well. What about a beautiful Spark cluster? It's in the cloud, it scales. Did I fix anything? No.
Well, I mean, it does change a few things for your productive system, right? So you will be able to train on top of the complete data set. You will not have to work with a sample that possibly represents your data set. But you won't be able to work in pure Python, right? You'll have to work with a different framework here, and that is not as simple as it sounds. And then, you know, going a little bit further, have you ever configured a Spark cluster?
There is no Spark cluster for dummies.
No. So you actually have to configure that so that it actually serves your need, you know? And then it's tricky because Spark clusters, they promise so much, but then you have to understand data distributions and you have to make sure that the data is not being reshuffled left and right, because then it's not going to be much faster than that Python prototype that you built.
Yeah, but how do you do that? This data scientist stuff is quite complicated here. I mean,
Yes, it is.
Oh my God, this is me after a few months into the project. Oh my God.
So, well, I think it sounds familiar, right? You build your project, you get started, you're trying to get through IT, you want to set something up, and it feels like this, right? So what is our point? Let's get out of this role play and get to the point.
Let's get
right?
serious.
How can you shortcut this process? There we go. So we have 3 pieces of advice for you in these remaining 3 minutes, let's say. First of all, my advice would be don't try to solve everything with one machine or one language. It has to be a combination of both, of multiple languages possibly even. It's not Python or Spark. It's not, building fully SQL or going full VM. You have to figure out a combination depending on where your data is lying and the task that you're trying to achieve, right? So you wouldn't believe how many of my clients actually end up doing things finally in SQL that they have been running on Python scripts for hours and hours, and an SQL engine can actually solve that in a few minutes. It doesn't have to be Python all the time, every time, right? So doing this will also save you a lot of refactoring time, because if you write that, if you write your product already in the code, in the language on the machine that is potentially production ready, you won't have to go through the whole process of rolling up your whole prototype again and rebuilding it so that it's production ready. Next, and that kind of plays together, right? You need an environment or a sort of platform that is a vehicle for your production system. So start getting your IT teams, I guess, to set up an environment where you can develop in a place that is already has the configurations that your productive environment would also have, right? So for instance, the data access could also already be sorted out. You don't have to figure out your data access for the infrastructure underneath and which languages you're going to be using, right? So think about this, and again, if you have this sort of environment, putting things into production will be much simpler, because at the very least, you've accounted for the actual productive data and not just a sample of it.
And the last point, try to push down the computation to the data. Don't have 2 platform, one the analytical platform and the other one the computational platform. Data is just too big for that. I work in the pharmaceutical industry. Genomic data, I have one table with 1,000 genome project is 250 terabytes, no joking, okay? Second thing, if you start moving data around, you have to really wait for this data to be copied in the other platform. The second thing, the other problem that you have is cost. Copying data, cost. Egress fees, for example, if you are in the cloud and so on and so forth. But the biggest topic for me is actually the taking risks. Platform provide a security model. In Snowflake we have columnar security, data masking, row-level security, and so on and so forth. Once you copy the data to another platform, you're going to lose all that. And you know how it works in the data science team. You copy the data somewhere, somebody else wants to use that data, you say, hey, I give you access to that, and so on and so forth. If the policy changes in the analytical system, then this is not reflected in your computational platform. Thank you very much for the time. I hope we didn't bore you that much. Food is served. We were a bit faster, so probably you can grab the best food before everybody else.
Thank you, Daniel. Thank you, Leah.
Thank you.